Okay, back from chapter 7, on to chapter 6. Have everything ready. PowerPoint, got my pad, got my ribbon, I'm good to go. So, chapter 6, we're going to start with areas between curves. So, just like integration is finding area between the curve and the x-axis, we can actually use integration to find area in between two specific curves. Now, this only is true as long as I know where one function is greater than another. Okay? So, because again, I'm trying to find the area between two curves, I need to know which one is above the other. Because the way it's going to set up is as long as f is greater than g, then the area is equal to the integral of whatever interval, let's say a to b, so a to b, of f of x minus g of x. So you just subtract the two functions and then find the integral of it. Antiderivative. I would say that's the whole lesson, okay? But you know it always gets harder. Move on. And again, I'm not going to go through the Riemann sums of this, okay? I'm just going to go straight to the setup right here. And here's basically the theorem you need. As long as f of x is greater than g of x, then the area is equal to the interval, whatever interval we were looking at, of f of x minus g of x. Okay? So for example, find the area of the region bounded by x squared plus 1 and y equals x. So we know the graph of these two functions. So y equals x is pretty easy, just line. But x squared plus 1 starts at 1 and goes 1 over 1. So if you plug in 1, you're going to get 2. So this is the area, and this says bounded from here to here. So this is your A, this is your B. So we're going to integrate from 0 to 1. The bigger function happens to be x squared plus 1, and the smaller function, y equals x. So we're finding this area right here. So since x squared plus 1 is greater than x, it's going to be x squared plus 1 minus x, where again this is f of x, is g of x, and there's no point on this function where f of x is no longer greater than g of x. No point, no position on the interval from 0 to 1 where f of x and g of x change positions. So this is a setup. We do the antiderivative. So f is 1/3 x cubed plus x 1/2 squared, and then 0 would just be 0, which is, so really I just have to find f of 1 minus f of 0. Worry about that. So f of 1 means plug in 1, and I get 1/3 plus 1 minus 1/2, so which is 1/3 plus 1/2, which is 5/6. You were right. So now I'm going to keep going. All right. Here's the problem we run across. There may be instances where f of x and g of x trade places. So here's where this website is going to come into play so much. Desmos. Use Desmos. Okay? You have your cell phones, you have your computers, you have something. use Desmos to make the graphs, and you can actually plot out so easily on Desmos where the functions change place. Now here, honestly, here a lot of people are moving on to Desmos because it's such a great tool to use. So feel free to use that during any homework or any quiz or test that I give. All right. So basically, again, the true expression is this. It's the absolute value, which basically means we have to figure out where in the function g of x is greater than f of x and where the function f of x is greater than g. So here's our function right here. Find the area of the region of sine x and cosine x from 0 to 2 pi, or pi over 2. So let's go back to Desmos. See if I can do trig. Here we go. Let's do this one. Graph. We have, I'm going to change this to cosine x, this to sine x. That, I don't need that. And I'm going to do 0, y equals, or x equals 0, and x equals pi over 2. Over 2. I'm going to zoom in here. This is our function. Make note of all the important parts. And this is what you can do. If you double click on any point, it brings it up. And by the way, this is the square root of 2. Square root of 2 over 2. You remember pi over 4, sine and cosine are both the same value. Really not important, to be honest. So here's a function. So we're trying to find this area right here. Area right. Now, there's a couple ways we can do this. Because we know these areas are the same, I can just do 2 times the area from 0 to pi over 4 instead of 0 to pi over 2. Because we know these areas are equal, we could do that. We can just say, instead of doing the integral from 0 to pi over 2, f of x minus g of x, I can do the integral, or 2 times the integral of 0 to pi over 4, just because, again, I happen to know they're equal. But that's not what we're going to do. Okay, what we're going to do is, again, cosine, this is cosine, right? So cosine is black, sine is blue. So cosine is greater than sine at first, so it's going to be the integral from 0 to pi over 4 of cosine x minus sine x dx, plus the integral from pi over 4 to pi over 2 of sine x minus cosine x. Right here, function changes at pi over 4. The function changes where sine x is now greater than cosine x. So that's how we're going to set it up in majority of all the cases. And again, just because we know these two are equal, I could just times this. But I'm not going to, because I need to show you the correct way to do it. So antiderivative, capital F of x. We know the antiderivative of cosine x is negative sine x. Derivative of negative sine x is negative cosine x. Okay. Here we have, actually no, because yeah. Now here it is negative sine, or negative cosine x. Yeah, so this is negative. Wait a second, this is sine x. Derivative of cosine is, derivative of sine is cosine, so the antiderivative of cosine is sine. That's good. The derivative of cosine is sine, so the antiderivative sine negative cosine, this is going to become positive. I believe that's it. There should just be sine x plus cosine. And here it's going to be actually backwards. It's going to be negative cosine x, negative sine x. Okay. Because again, here they're both switching positions. All right. So here we have from 0 to pi over 4. Now it happens to be that 0 gives you 0 plus 1. So f of 0 is 1. F of pi over 4 is 1. This happens to give you 0. That doesn't make Oh, no. So f pi over 4 is root 2 over 2 plus root 2 over 2 root. So we end up with root 2 minus 1 for the area of the first function. 1. And then the other one, we get pi over 4, we need it to be root 2 minus 1. Over 2 should be 1 because negative 1. We get negative 1 minus a root 2 minus 1, which is negative 1. Oh wait, these are backwards. It's going to be still going to be negative 1 because cosine minus 0, that's negative 1. F of pi over 2 is negative 1. F of pi over 4 here is a bit different because it's backwards. It's going to be negative root 2 over 2 minus negative root 2. That's going to become negative 1 minus a negative root 2. So it becomes root 2 minus 1. Again, the same, should get the same answer. So we have 2 of this, ends up being the whole thing is 2 root 2 minus 2. Awesome, right? So let's look at the answer key. PowerPoint, see how we did. So clear this. Yep, doing good, doing good. 2 root 2 minus 2, the correct answer. So, pretty good. And again, like I said, in this particular example, we could have saved some work noticing the region is symmetric. Again, you saw it, I saw it, it's fine. Now, here's the fun part. Notice I said, here's the fun part. Sometimes the region is not going to be bounded by x, it's going to be bounded by y. It means your functions need to be in terms of y, which isn't going to change anything except for when your functions are not in terms of y, you're going to need to make them in terms of y. And a good example of that probably be, let's see. See what I mean by number 3 here? The function is in terms of y, x is in terms of y, x is in terms of y, and the region is bounded from 0 to y equals 1. So not an issue, right? The issue comes when x is not in terms of y, but the region is bound by 0 to y. That would be somewhere on here. I know it's somewhere. Seen it. No, I did. Come on. Don't make a lie. Oh, right here. Number 11. Here one function's an x and the other function is y. We would have to square root this. So y would equal the square root of x. Okay. Technically you do plus or minus square root of x because it would be both. But still, that's what you'd have to do, and probably just the positive square root of x, because that's the only part that would interact. And I'll show you what that looks like on a, hey, we have Desmos, let's do that. Clear this, go back to your blank graph. We had y is equal to x squared, and then we had, and again, we could type it as x is equal to y squared. But this is going to be difficult to put this in terms of integration. All I want is the top half, this part right here, this part that's in blue, which would be this. If you solve for y, you would get y is equal to plus or minus square root of x. Now, being that I'm not worrying about the negative part, I'm just going to say y is equal to positive square root of x. So I'm going to put that in here instead. So y is equal to, you actually could do square root right here, square root of x, and notice that it turned green. I don't even need this anymore. I have what I need. Zoom in a bit. So this function is going to be quite simple. It's going to be the integral from, again, I can click on this and see where they intersect. Right, so 0 and 1. So I'm trying to find this area in between here. So it's going to be the integral from 0 to 1, because that's where they intersect, of the greater function. The bigger function is square root of x, minus the smaller function, x squared dx. And again, it might be easier to write it as 0 to 1 of x to the half minus x to the 2 dx. So antiderivative equals, if you add 1, you're going to get 3 halves, so 2/3 x to the halves minus 1/3 x cubed. And again, if you do f of 1 minus f of 0, it's always f of the upper bound minus f of the lower bound. Where f of 1 is equal to 2/3 minus 1/3, so 1/3. F of 0 is 0, 1/3 minus 1/3. So that is the between that. Isn't that nifty? All right, so let's do a couple more of these. Again, Desmos is going to be a big help. So I'm going to get rid of this. I'll do this. I'll put this here. I'll put Desmos. Desmos. Okay. So I mean, we could do the trig functions, and that's fine. But let's look at, I don't know, number 18. So y is equal to 8 minus x squared, so minus x squared. And y is equal to x squared. And we're going to bound this between -3 and 3. Hey, yeah, that changes things. Because here, if we didn't have that information, if we didn't have this information, we wouldn't worry about -3 and 3. And x 3. And here's where in class, let me zoom out a bit so it's better. here's where in class that I would ask you, someone to come to the board and solve this for me, but I'll have. But I'd also ask, what's the importance of having these values? Well, that's where, if you notice, primarily the red function, the first function, is greater, except it is not greater once from -3 to -2, the green function is bigger, and from 2 to 3, the green function is bigger. And again, why not do this? Why not just use that since we know this is symmetrical, it is obviously symmetrical, from 0 to 3, it's symmetrical. So what we're going to do is we are going to do this, which is I'm only going to find the area of this half. So this area and that area. So that means the integral from 0 to 2, where the red function is bigger, 8 minus x squared minus the green function, x squared, x, plus the integral from 2 to 3 of the green function, x squared, minus the red function, 8 minus x squared. So that's what we're going to do. Well, let me go ahead and close words, so I need room to write. I already know what the graph looks like, so don't. Let's do the integration. So, integral from 0 to 2, since I'm going to simplify this, 8 minus 2x squared. So, x is 8x minus thirds f of 2 minus f of 0, where f of 2 is 18 minus 8 16 f of 0 is equal to 0. Worry about that. So this becomes 32 over 3. So, let's see here. Now we need to do the other, which is the integral from 2 to 3 of that. So I'm going to change the sign. This is negative. That's positive. It becomes 2x squared minus 8x. F of x, capital F of x, the antiderivative, would be 2/3 minus f of 3. Now that is 27, 2/3 of 27, 24, 6. And then f of 2 would be 16 over 3, 16, be negative 32. So negative 6 minus a negative going to be negative 18 over plus 32. Again, my pad's jumping around here. It's going to give you positive 14 over 3. Add that together. 32 over 3 plus 14 over 6 over 3. Or what? 15 and 1/3? Nope. Okay, so we're good. We're good. Everything's fine. This is what I'm going to give you guys for homework. I mean, really, it's going to be just all the same stuff as what we're doing. So what I'm going to give you would be just do 1 through, let's keep it simple. 1 through 21 odd. Okay, so not a lot of questions. 1 through 21 odd. We're good? We're good. All right.